Now do the things that are on the board. And take your green tabs down, put your green tabs up when you're done with that. By opening your R script from the location where it's at, R automatically sets that directory as your working directory, so you shouldn't have to set working directory, but check that anyway. Control Enter for you guys, yep, if you're on a Windows machine. Yep. What's that? Okay, let's see. Let's see. Somebody in Windows, where do you find the open with? Go back. Go back and right click on it. Let's see. Wait.
This is the brand new Windows, so I don't know if it's
Show more options. Well, that's weird. Okay. Go back there. Used to be under Properties. Okay, go back to Properties. Go to Advanced.
Won't let me click on Advanced.
Won't let you click on Advanced. Hold on. Go to Customize. Oh, that is weird. Should be here. Why is it showing it as a read-only file? How do you right-click on your guy? Right-click. Okay, wait. Oh, there's Open With right there. Go to RStudio. I don't know why it didn't pop up. Okay. But let's go back now that it's open in RStudio. Did you do two fingers?
Yep.
Oh, that's weird. All right, I don't know what that is. Okay. Excuse me. What's up, Cole?
Is it saying just doing a warning message? I'm sure it still works.
Oh, that's fine.
Okay.
Yeah, that's a good point. All right, looks like everybody's up to speed. Is that correct? All right, green tabs down. Let me get caught up with you, actually. Oh yeah, and you should have quotes around Our Markdown. I always forget the quotes when I write stuff on the board. Occasionally you will get warning error messages from R, and what the deal is R gives you two kinds of error messages. Some error messages are to tell you about something that has gone catastrophically wrong in R, and it won't let you go any further. Other messages are the message that some of you got, which is just basically telling you that Our Markdown was built under an earlier version of R. You're working with the newer version of R because you just downloaded it and installed it, and whoever wrote Our Markdown hasn't updated it since the latest version of R has come out. All it's telling you is that if it behaves a little strangely, that's probably why it's behaving strangely, but you don't really need to worry about it. So when you see an error, they all appear in red, but read the error. Generally, errors that make clear sense to you are just informative errors saying things like this. Our Markdown was built in a different version of R. Be aware of that. Usually the catastrophic errors are so cryptic that you can't even tell what it's telling you is going wrong. And so kind of like the error that we had on Monday about \u is not hexadecimal. Well, what the heck does that mean? That doesn't tell me anything. So read the errors, try and figure them out. If it's a catastrophic error, it will, in many cases, not give you the output that you were asking for. So one of the things that you will see with me as I script in R, and we'll talk more about this later, is I generally have a pattern to every R script that I have. The first thing that I do in an R script is I check my working directory. I run get wd. Once I know that I'm in the correct working directory, the next thing that I do is I load all my packages. If I think I'm going to need a package in a particular script, I will put it at the very top of the script. Then I know that I don't get an error message later on telling me that the package that I'm asking for is not installed, and then I have to install it further down. Then once I've done that, I read in my data, if I'm reading in data from someplace else. And then after I do that, I look at the data. And I'll show you some ways to do this today. And whenever I ask R to do something, sometimes R does something and it doesn't do anything more than do what R did this time. I asked it to load our Markdown, and it just returns the command prompt. That command prompt basically is R telling you, I did what you asked me, what do you want me to do now? And so a lot of times, you'll run a line of code, you'll get the command prompt, but I always like to verify that it actually did the thing I asked it to do, and I also like to verify that it did it the way I thought it was supposed to do it. And so you'll see in my scripts, a lot of times I'll issue R a command, and the next thing I do is I check to see that it did that. And so a lot of my R scripts are just command and verify. Because I don't really trust computers. They're going to take over the world and subjugate humans and kill us all. Or put us in little pods and use us as batteries, depending on what form of science fiction you're into. So always verify that R is doing the thing that you ask it to do. How can we verify that our Markdown is loaded? Not a rhetorical question. Yeah.
It's just that our library, our Markdown is over there.
Nope. It tells you that it ran it, but it doesn't tell you that it really ran it. Where can we go and verify? Yeah, we can go to packages, and we can see if it's checked. Our Markdown is checked. That tells us we asked R to do something, it actually did it, because before we did that, our Markdown would not have been checked. Remember, you can load packages either by using the library command, or you can just load packages by clicking the box. I find it more efficient to just type library R Markdown. Yeah?
What's the difference between the user library and the system library?
Where are you at?
I'm just looking at.
Oh, yeah. Okay, so yours is divided. Mine's all one thing. There are certain packages that just are in base R when you download base R. Those are what we refer to as system packages, and then there are packages that you actually add, and those are user packages. So base R comes with a bunch of functionality, and so you can do quite a lot in R without relying on these other packages, but you are inevitably going to run into places where you're going to work more efficiently and more elegantly if you have packages loaded. All right. So I'm going to give you Markdown files whenever I want you to work on a project and I want you to use code that I've generated. And the reason that I give you Our Markdown files is because I can save them as a PDF, and by saving them as a PDF, it's harder for you to just cut and paste my code into your script and then run it. So the nice thing about Our Markdown files is that they look nice, and so you can have long text between code chunks that then allow you to put a lot of comments in there. So I have a number of Markdown files built for you guys that take you through analyses, and there's a lot of explanation because they're really teaching files. They're not actually the kind of files that I would write if I was writing an analysis. When you write your report, you could write your entire report in R Markdown. And actually, I'm going to require that you write your entire report in R Markdown, because then you can just give me the R Markdown file. It shows me the code that you wrote, but then it also shows me the output that came out of that code. And so rather than do what I used to do in the old days before R Markdown was such a thing, is I would have you give me your data set, give me your R script, I would download those onto my computer, I would run it to make sure that it ran correctly and it gave me the outputs that I thought it should, and that it gave me the outputs that match what's in your report. So you would turn in a written report done in something like done in something like Microsoft Word. You would turn in an R script and you would turn in a data file, and I would have to wade through all of that stuff. Now I can grade more efficiently because I can just have it all in an R Markdown file. So I want to introduce you to R Markdown because that's how you're going to be functioning for a large portion of the rest of the semester. So is everybody now in the right directory? Okay. So now what I want you to do is I want you to go up to File, and under New File, I want you to choose R Markdown. And click on that, and it's going to open a box, a dialog box, and you want to name it something descriptive. It will have you as the author, and you can save it. I would save it as an HTML. That's the easiest way of saving R Markdown files. Once you've done that, you will get a new R Markdown, and what you should do is you should save this immediately as whatever you want the file name to be saved as. I'm just going to use R intro once again. And you notice that this is a .rmd file, not a .r file. Put up your green tab when you've accomplished this.
So, how did you go to save it once you...
There's a little disk button up here. There you go. Or you can go to the file menu. Yep.
I missed the first part. Which button?
Okay, go to is that an R Markdown file? So go to save.
This one or
Go to that. Okay. Where's your? Go to the plus. You want to open up an R Markdown file, and then put in the title for it, and your name is author.
So I still have mine in the wrong directory.
Okay.
What is it on?
Are you on your desktop?
Yes.
Okay. So go back to R. So get WD. Run get WD again. No, you're in the right directory. Yep.
Whenever I push save, it just said error saving.
Well, that's weird. Go back to, wait a minute. Go back to your desktop, because it's saving it to documents for whatever reason. Go up to File, Save As. Okay. Oh, because you're dealing with iCloud. Yeah, go to your desktop, but not in iCloud.
Oh.
Where's your hard drive? Why is that not coming up as one of your possibilities? All right.
Yeah, that was one of my questions I was going to ask last week because I couldn't find my. It doesn't even show.
You have to go to Preferences. Show your hard disk. Okay. Now let's see. is. Oh yeah, there we go. So now your desktop is there. Oh, but that's your iCloud desktop. Oh, it's not doing it because your iCloud storage is full.
Yeah.
You can't store stuff in the cloud if you're actually full. So let's go to yeah, so that's why it's not saving. This is all in the iCloud. Where is your hard drive?
Yeah, I don't know.
That is irritating. Who are you? Oh, Austin. Okay. You don't have the desktop. That's weird. This is going to be difficult. Okay. Okay. Yes. Okay, now that's stored on your actual hard drive, your physical hard drive, and it's in your user space. So now let's go back, close R, and open up our intro from here. Any other pink tabs? Excuse me. All right. When you've got that done and it's saving it, take down your pink tab and then I'll proceed. Take down your green tabs, those of you that are done. Did it work?
I got it open.
Oh, you got it open. Okay, all right. Yeah, yeah, yes, click yes. You want to get rid of that. All right, now get WD. It's in your user account in Applied Stats, our intro. Now you should be able to save it. So now run our Markdown.
Do I need to change the set WD here?
Just get rid of that because you opened it from inside the working directory where you want to be. So you don't really need to use set WD. All right. Now go up to File. Get a new file. What? New file. Our Markdown. Okay, wait. Go over here. Go down to where our Markdown should be. Oh, yeah, it's right there. Okay. Uncheck it and check it again. Okay, now try it again. Okay, wait, hold on. Go ahead and install it. Yep, just do it. You must have a package that's not updated. Okay, all right, there you go. All right, put a title, put your name as author,
All right.
and then once you're done with that, save that file. So this Our Markdown file is the file that we're going to be using for the rest of this. I realize I started you outside of Our Markdown, but I needed to start you in R in order to get Our Markdown on your computers. So now we're going to just do it from here. So at the beginning of this, it gives you a brief introduction. It's the briefest, most useless introduction on the planet, but it tells you about Our Markdown. Things that you need to do here at the beginning in Our Markdown is you need to go up here. There's a knit button, and there is a little gear right here. Under this gear, you can preview in the window or you can preview in the viewer pane. Click preview in the viewer pane, and what it will do is when you knit your Our Markdown document, it will show up in the viewer pane so you can see what it will look like. Is that safe for you?
Yeah.
Okay.
But it's not showing up as how you were talking about it.
Yeah, so do save as, file, save as. Yep. And give it a name.
Okay.
Give it a useful name. Now go to the gear, knit to the viewer pane. Oh dear, lots of pinks. Yeah, what's up?
It just didn't do anything.
Yeah, same with me.
I got one here and I clicked this one.
Yeah, that's all you need.
Oh, it doesn't.
Yeah.
It doesn't
No,
do
it doesn't do anything.
Oh, okay.
You're just telling it where to put it later. Yep. Nope. Nope. You shouldn't see any change, except the check moves from where it was to where it is now. So the goal of this is that in an Our Markdown document, you can have a bunch of text comments that tell the reader stuff that you want them to know, but it's not embedded within your code. It's outside of your code. And then you have these little things called code chunks in gray. This is a code chunk, and it's preceded by 3 apostrophes and followed by 3 apostrophes. You can get a code chunk to appear by doing that, but it becomes a total pain in the butt. So it's good to know some keystroke shorthand stuff. So go down to line 31 and do Command Option I. And Command Option I should give you a code chunk. And is that the same in Windows? Or is it Control Option I? It's Control Alt I in Windows. So in Mac, it's Command Option I. In Windows, it is Control Alt I. And that gives you a code chunk. And you can name these code chunks. So in this code chunk, after the little R in the ellipses, put addition. And then in the code chunk right underneath that, we're going to add 4 plus 2. Put up your green tab when you've got that typed in. You formed a code chunk.
Do you want us to run that?
Yeah, if you've got it in, go ahead and run it. If you run it and it runs and gives you, when you run it, it should give you output both in the window up there, and it should also give you the output down here. So if you got 6, leave your green tab up. Clara, you got it? Still working. Still working. Okay, that's fine. Okay, green tab's down. R has a lot of functionality. You can do basic math in R. Let's add another code chunk down below that. Let's call this R chunk division. You can do simple division as well. Let's do 4 divided by 2. Run that. Once again, because it's simple division, we can figure out the answer for ourselves, but we can also check to see that R is doing math correctly. Now, did everybody get that done? Okay. The reason I'm putting names at the beginning of each of these chunks of code is because if you go right down here, you can see this little green tab right here. It says chunk 5 is division. If you're naming your code chunks and if you get a really long script, this basically creates a table of contents in our Markdown. So if you need to go back to setup, you can quickly and easily navigate back to setup. If you want to go back to addition, you can go to addition. If you want to go back to the section called division, you can go to division. So by naming these code chunks with names that intuitively mean something to you, it helps you, especially if you're working with a 400 or 500 or 1,000 line script. It helps you go and find places in your script if you're indexing it this way. So I find it useful to do that. Green tabs down. You do more complex math. So give ourselves another code chunk. So as long as you know what the order of operations are, R follows the same order of operations. So we could actually do 4 plus 2, and then we can multiply that times 4 divided by 2. And it should give us the answer 12 because 6 times 2 is 12. And voila, it does it correctly. We can do basic math. Everybody there? All right, good. There's a new command that I want you to learn a shortcut key to, once again, because it's just going to make life easier on you. You can assign commands to shorthand tags using a thing called the assignment operator. So let's say that instead of doing division by itself, we want to actually assign that equation to a label. So give yourself another code chunk. We'll call this code chunk the assignment operator. And what we can do is we can say anytime I want to do the division of 4 divided by 2, I can just assign it a shorthand tag. So if you're on Mac, do option plus the minus sign. If you're in the Windows version, do Alt plus the minus sign, and it will give you the assignment operator. So this less than sign followed by a dash, this is the assignment operator. And when we do 4 divided by 2, what we'll get is we'll get nothing down in the pane below us. Because what we've done is we've basically said, whenever I want UR to divide 4 by 2, I'm going to say div for division, and then you're going to divide 4 by 2. So if we want to see the outcome of this, so all this is done at this point is it's stored 4 divided by 2 under this tag div. If I want to actually do it, all I can do is type in div, and it will do the thing. So the way the assignment operator works is it assigns a name to a thing. That thing can be all sorts of things. It could be a graph that you're creating, a plot of some type. It could be a function. So you can write a big, long function, name it this shorthand thing, and then you don't have to repeatedly type that function over and over again. So this helps you in lots of ways. I will oftentimes read in data files, and then just so that my R scripts are consistent from script to script, I almost always shorthand my data files DAT. Just call them all DAT. You don't want to call them data because data is actually command in R. So if you try and use the command data to do something like refer to a data file or a data frame, it's gonna complain at you. So you can DAT. You can read.csv. This is just the command for reading in a comma-separated values file, and then put the file name for whatever file it is that you want to read in. So anytime you need to access this file, you could actually type read.csv and then the file name, but you can use the assignment operator to just give yourself a shorthand tag that basically says, whenever I write DAT, I want you to read in the data file. And then whenever you type DAT, it does that thing. So the assignment operator is your friend. So in this same little code chunk, let's do add. And the assignment operator, and do 4 plus 2. Run that, and then verify that it actually did it by typing in add and running that. You should get 4 plus 2 is 6. Put up your green tab when you've completed this. Oh, so you didn't run that line? It's object not found. You're telling it to do something, but you haven't already had it do it. Yep, command enter. Now do it. There you go. Yep. Oh, okay, good. Yeah. Object not found. So whenever it says object add not found, you wrote that first line. You wrote this line, but then you didn't execute this line. So go back to this line and execute it, and then execute this line and see if it gets rid of that error. If it did, all right, green tab's down. The cool thing about these shorthand tags that you're giving things is if these shorthand tags are mathematical tags, you can do things with them. So for example, we could take the tag add and multiply it times the tag div. What we should expect to see when we do that is it should take the division, which is 4 divided by 2, which is 2, and it should multiply it times the addition, which is 4 plus 2, which is 6. So this should give us the multiplication that we did before, which was 12. Let's run that, and it actually does that. So add and div are just shorthand tags that stand in for either, in the case of add, 4 plus 2, or in the case of div, 4 divided by 2. Everybody get that to work. This is just basic R kind of functionality that we're going through. Well, this is stupid, because who's going to do common math on R? You have to boot up your computer, you have to open up R, you have to start a script just to add 4 plus 2. Everybody knows 4 plus 2 is 6. But the point is that you can do any mathematical operation in R that you can do in the real world. So let's start to do some things that are more complicated. So give yourself another code chunk. Command Option I again. And we're going to call this make a vector. So a vector is a list of values, essentially. And we can build vectors up. We can build data sets up. You can build a data set within R. So what we want to do is we want to make a vector. We'll just call this a vector X. Because we're making it a vector, we need to give it the assignment operator, and then we just need to give it a set of values. And so the set of values that we're going to give it is 1, 2, 3, 4, 5, 6, 7.
Wait, do you have to do that like C and then open it?
Yes, you do have to do the C and the open parentheses. The C stands for concatenate, and so it's concatenating these values into a vector.
And then when we enter like values into that, you want to just separate them by a comma?
Yep, you separate them by a comma. Otherwise, it'll just read it all as a single value. Yep. So in this case, it's like computer programming in that syntax does matter. So if I ran it this way and then asked it for the result, it gives me 1, 2, 3, 4, 5, 6, 7. If I got rid of the commas, it would give us a different answer. 1, 2, 3, 123, 4, 5, 6, 7. Okay? But we actually want 1, 2, 3, 4, 5, 6, 7. And so this is a vector. Put your green tabs up if you got your vector built and have verified it. Oh, okay, get your green tabs up. All right, green tabs down. Uh-oh, what's wrong? Oh, you got it, you figured it out. What did I not do? So I just ran X again. I didn't rerun the creation of the vector, so now I have to go back and rerun the creation of the vector. So now we have this first vector that we've got here. We have 7 numbers because I'm trying to build a data set that has days of the week in it. So I can build another vector called day, and I can assign this vector a set of values. First value will be Sunday. Then the second value will be Monday, et cetera, all the way through to Saturday. Put these labels in parentheses or in quotes because it's just being read in as text. When you've done that, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, when you have done that successfully, run that, and then once again verify that it actually did it. I saw you. I was just finishing what I was doing. Yep.
I don't know why it didn't do this. Oh, it's because I have arm make is not.
Oh yeah.
Okay, that's my fault. Yeah,
Give it a space. Yep. See if that fixes it. Yeah. Okay, so run this line. Execute the line that makes the vector. Now do X. So you typed that in, but you didn't execute it. And then you try to run X, and it's like, you didn't tell me what X is. So you have to tell it what X is. So when you type this out, the first thing you should do is execute that line of code.
Okay.
Okay? All right. Yeah. Oh, that is weird.
But I did it like you did.
Because you got 4 minus 2 instead of 4 plus 2 in your formula.
So I did minus.
Oh, well, it's not there. It's down here. Down a little. 4 minus 2. Yeah, because it's an addition. Yep. See if that did it. So re-execute that line.
Yeah.
Blaine, still have a problem?
Yeah, no, I'm just doing the second one.
Okay, all right. Okay. We'll continue to build up this data set. I have chickens in my backyard. So if I was really interested in egg production of my chickens, I might want to know whether there's a difference in the days of the week that our chickens produce eggs. So for example, on the weekends, we are much more likely to go out and play with the chickens and give them attention and give them treats and things like that. Who knows, that might affect the production of eggs. So let's look at some egg data. And so we'll have a new vector, eggs. And for a given week, my chickens produced 4 eggs, then 6 eggs, then 3 eggs, then 5 eggs, then 7 eggs, then 6 eggs, then 4 eggs. So there should be 7 things here. 1, 2, 3, 4, 5, 6, 7. We'll run that, and we will check to see that it did it. And there are the number of eggs for each day of the week. So now we have 4 vectors, or 3 vectors rather, a vector that just numbers the day of the week, a vector that has the days of the week in terms of their names, and a vector that has the number of eggs that my 6 chickens produced in my backyard. Green tabs up if that worked for you. All right, green tabs down. So this is a set of vectors, but what we haven't really done yet is we haven't built a data set because we don't have all of these vectors of data put together into a full data set. But we can do that because we can actually just take these vectors and combine them into a data frame. So I like to call my data frames DAT. Well, let me do this. Make a new code chunk. And call this new code chunk make a data frame. So what we want to do is we want to make a data frame, we want to call it DAT, we want to use the assignment operator to assign a name to this data frame. And what we want to do is we want to type in the command for making a data frame, and then open the parentheses, and then within this data frame, what we want to do is tell it what we want to be in the data frame and in what order. So the first thing we want is the X variable telling us the numerical days of the week. We want the day of the week, and we want the number of eggs. If you run that and it didn't give you an error, it should just give you the command prompt. So to figure out if it actually did that, we can just get it to show us the entire data set. Green tab up when you've done this, and it worked. With a small data set like this, you can just type in DAT, and it will just show you the whole data set. Coming through. You got it? Okay. Green tabs up everywhere, green tabs down. All right. When it's a small data set like this, you can just get it to show you the whole data set, and you can see everything that there is to see about the data set. But this isn't always the way you want to do this. If you have a data set that has 1,000 lines of data in it, you don't really want to see the whole data set to verify whether or not it read in the data correctly. So there are some ways in which we can figure out what's in our data set without seeing the whole data set. So make yourself a new code chunk. I'm going to call this verifying data. One way of checking to see if your data read in correctly is to ask yourself, do the columns match up with what you thought the columns were going to be? Well, you can look at just a couple of lines of the data set to figure that out. If you type in head and then the data frame name, what that does is it gives you the first 6 lines of your data frame. So in this case, it only gives us the data through Friday because we are only asking it for the first 6 lines. If you have a really long data set, but you know the dimension of your data set, you might know that your data set is 1,000 lines long. Well, one of the things that you could do is you can not only check the beginning of your data set, but you could also check the bottom of your data set. If head is for the top of your data set, what would be a good command for the bottom of your data set? Not foot, but what's at the opposite end? Somebody said it. Not toes. Tail. So type in tail. Get the tail end of your data frame. Once again, now you can see row 1 is gone, but you have the last 6 lines of your data frame. And if you have some index for your data frame within your data frame telling you what line of data you're on, it's really easy to see. If you have 1,326 lines of data, this should read 1,326. Yeah?
Do all the columns have to have like an equal number of rows?
Yes. So if you try and make a data frame and one column has 7 values, another column has 6 values, and a last column has 7 values, you're going to get an error message. So whenever you create a data frame, it either has to have all the same number of values, or if you're missing data, you need to have a missing data code in there. Usually NA is what people put in. Sometimes people put in 999, but you then have to tell R what you're coding missing data as. But yeah, it won't let you put in a data frame that doesn't have an equal number of observations in all the columns. That's a good point. In reality, people don't generally build data frames like this in R. This only really works for small data sets that you might use in a class. If you're using real world data, you're importing that data from someplace. But once you import the data, it's always important to know, did R import the data incorrectly? And do they look like what I expect them to look like? So these data checking steps you're going to be using all along the way. Now, other data checking methods we can do. We can also use a command called structure, str. What I like about structure is it basically summarizes your data for you. And so in this case, it's telling us that our data frame, DAT, has 7 observations and 3 columns worth of data. The first column is X, the second column is day, the third column is eggs. It also tells you the type of data that R is reading this stuff in as. So it's reading the X data in as a number, it's reading eggs in as a number, and it's reading the days of the week in as a character. And that's exactly how we want R to be treating those text values, is either as a character or as a factor. If we were doing something like running an analysis of variance, we would want it to treat day as a factor. So let's make a new code chunk down here. I'm going to just call this changing data types. If you have a big data set and you don't want to run something like structure, but you have particular variables that you know that you want R to treat in a particular way, one of the things that you can do is you could ask it about how it's treating that particular data type. And so to do this, we'll use the command class. And then we want to say, what classification are you putting this data in? And so in this case, we need to tell it what the data frame is that we're looking at. And then when you use the $sign to then indicate what column you're looking at. So I particularly want it to tell me, how is it classifying the column day in the data frame DAT? Run that, and it should basically tell me it's using it as a character. Green tab up if that worked for you. Oh, scanning the room. I just got to you. Okay. Oh, lowercase. Case is important. You will notice when I built this data set, what did I do with all my variable headings in terms of uppercase or lowercase? It's all lowercase. I hardly ever use uppercase in R because virtually all of the commands are lowercase. Also, I try and avoid putting spaces in variable names because when you import data into R, it will replace that space with a dot, and then you have to be typing out this dot. So I'm always thinking ahead as I'm building data sets. How much trouble is this way of organizing my data before I get to R? How much trouble is doing it that way going to give me in R? And so I usually try and simplify things by using lowercase, avoiding complex names for variables at the heads of columns, et cetera, simply because it's so much easier to write eggs than it is to write daily.egg.count. Because I might have had a column called daily egg count, but when R imports that in, it's going to replace this space with a period, and now I have to write a bunch of characters instead of just typing the simple word eggs. So as you're working with data sets, I may give you a data set in a CSV file. You may look at the headings at the top of that data set and say, that's just going to cause me problems in R. I'm going to rename these before I even import it into R, and then I don't have to jack with a bunch of typing. Keystroke errors will plague you, doing things like putting an uppercase letter where there should be a lowercase letter. Keystroke errors will plague you. They will dog your very existence. So whatever you can do to kind of simplify the keystrokes as much as possible, that's going to ultimately help you a lot. Character data is any text-based data. If you have a character, if you have a variable name like day 7, it's going to treat that as character data because don't type this in. I'm just showing you. It'll treat that as character because it starts with a letter. If you start with 7 day, it's going to treat that as character data because even though it starts with a number, it finishes with letters, and so it's going to treat that as a character. A character is different from a factor. A factor is a grouping variable. And so when we get to the point where we want to have multiple observations that all have the same tag, those aren't characters anymore, those are factors. So there are going to be times when we want to change how R is viewing the data. And we can do that by basically reassigning dat $day, use the assignment operator, and what we want to do is we want to put an as factor, as.factor, and then just define which column of our data frame we want to have reassigned. So what this basically says is, it says, I want you to make a new thing called dat $day. What I want you to do is I want to change that to being treated as a factor, and the thing that I want you to change it from is dat $day. And what it will do is it will just reassign the data type. So type that in, and it should just give you the command prompt, and then, as always, check and see that it did what you asked it to do by rerunning class. And now you can see that this is no longer treating it as character data, it is treating it as a factor. Green tabs up if that worked. Oops, red tab. What's up?
Not an error.
Ooh, okay. That's an ampersand, not a $. That fix it? All right, green tab's down. You can do math within a data frame. So let's say that you want to derive a new variable that is made up of variables that are already there. So let's make ourselves a new code chunk. And we'll call this code chunk math in a data frame. And so what we can do, for example, is we could take the old variable day, we can multiply it times eggs, and there's no reason why we would want to do this because day doesn't really mean anything, it's just the numerical value of the day of the week. But we can actually multiply these things together. Whoa, what happened?
Day is the actual.
Oh, day is the actual day. You're right. But this illustrates an issue. So I just tried to do day of the week times eggs, and it basically says there's an error. There's a non-numeric argument in a binary operator. All that's telling us is that you're trying to do math on something that you can't do math on. You can't do math on Friday. Friday doesn't have a numerical value. What I meant to do was I meant to do x times eggs. And when you do that, it will just simply do the multiplication of whatever the number of the day of the week was, multiplied times how many eggs were collected that day. Now we can incorporate this new variable, which I will just call molt. So dat $molt, which is using the assignment operator, simply dat $x times dat $eggs. And if that worked, you'll get the command operator, but of course we can see if it did this by looking at the top of the data file. And when we look at the top of the data file, what we should now see is there's now an additional column of data, which is 1 times 4 is 4, 2 times 6 is 12, 3 times 3 is 9, 4 times 5 is 20. Green tabs up if that worked. Red tabs up if it didn't.
Sorry, where are you going to see that again?
I just did the head. Notice there's only 6 rows. I just did head dat after I did this. So I did this, and it gave me the command prompt. I want to verify that it did it by actually seeing it.
I think I missed a step.
Okay, all right. So you need to always execute that line. So execute it. Nope. Just put your cursor on that line and then do command enter. So put it in this line. Activate it. Okay, now do head dat. It's already there. Yep. Ah, there it is. Okay, cool. Green tabs up? No. Some issues? Pink tabs up if you're having issues.
Sorry, I forgot.
That doesn't do.
I somehow deleted one of those two. Now
Oh, I can go back and show you what I had.
Yeah.
Just so you have a complete file. Let me do that. There it is. Let me go help somebody else while you fill that in. Did you get it?
Yeah, I think I'm good.
Okay, all right, good. Everybody good then? Give him a minute to catch up. Go to the Moodle site. From last class period, there should be a data file called what is it called? Oh, the Spanish flu data set. Pardon? Oh, did I? Oh, so it's already there. Okay, then you don't have to worry about that. So I don't think I have that in my folder. Let me go do that real quick. Oh, no, I do have it in there. So another way of getting your data into R is to just import a data file. So that Spanish flu data file is a CSV file, a comma separated values file, and you can import that file into R using the read command. So we're going to make a new data frame. We're going to call it the same thing that we called the other data frame. Oh. No, I have to make a code chunk, which I didn't make a code chunk. So I'm going to call this import a data frame. And so the way you do this is you make a new data frame. You're going to use the assignment operator. And then you're going to do read.csv. And then in this space, you're going to put the name of the file, which is SpanishFluDeaths.csv, and the thing is capitalized for each of those words. So this would be open parentheses, and then it's Spanish flu deaths.csv. And try and read that in. If you got the command prompt back, do the head of that to verify that it actually read it in. What you should have is should have a column of age, female deaths, male deaths, and total deaths. This is a pretty long data file, so you don't want to see the whole thing. If you wanted to see the whole thing, you could just type in DAC, and it would give you the whole darn thing. But you don't really want that. Green tab's up if that worked for you. Excellent. How are you feeling about your facility with R at this point? I feel like you probably didn't feel that great about your facility with R last time. Okay, good. Save this file so that you have this for your reference. We'll pick this up at the beginning of class on Friday, so just save it as a Markdown file. I'll show you how to knit that Markdown file on Friday. I'm also now going to have some homework for you to work on R on your own now that you're oriented a little bit to the way R is working. On the green tabs, things that worked for you today. Pink tab, things that could have gone better for you, things that I could have done better today. This time, put them together, green on top of red, so that I can keep the responses together, and then turn them in on your way out of class. No names. Yeah.
So I've saved it right on this little disk thing, right?
Yeah.
I go to close it. Oh, no mind. It gave me a weird message before.
Oh, it's gonna. Let me go through this real quick with you. That's a good point because I haven't shown you how to do this. So save it using the little save icon, but then when you go to close RStudio, it's going to ask you, do you want to save anything? It's going to say save workspace image. The problem with saving the workspace image is that's all the stuff that you've been doing, which preserves a lot of the mistakes you've probably made. So you generally don't want to save your workspace image. You just want to save the file itself. If you didn't save it just now, it would ask you, do you want to save workspace image and your R script? Unclick workspace image, click R script. That's what you want to save ultimately. So don't save that, and you're out of R. All right, good. Yes, ma'am.
Sorry, so you're just saying unclick.
Yes, you just really want to only save the script.
Okay.
Yep.
Thank you.
Yeah, cool.
Okay. So I was able to
Excuse me?
actually get it downloaded on my phone.
Oh, good. Oh, awesome. Yeah.
Now it won't change the working directory. I'm thinking it's because it's based on
You're in the cloud drive. So you
I'll
need to
just-
save all of this stuff on your regular hard drive. Make yourself a folder on your hard drive and do all your work there. Yep.
Thank you.
That'll just save you recurring hassles throughout the rest of the semester. Yes, sir. Uh-huh. Okay. Okay.
I just wanted to be honest with you.
Videos?
Yeah, and I was gonna say, do you want me to meet you tomorrow during your office hours too, if that works, or do you think it's pretty standard? I have taken DTS 350. So I have a little bit of
It's pretty self-explanatory, and you've already seen some of the stuff we're going to be talking about on Friday, so I don't think we need to.
Okay.
We meet next week if you look at the video and you're like, hey, we didn't do that.
Okay.
Okay, yeah,
Perfect.
yeah.
I can do that. Thank
Sure,
you.
no problem. Yes, sir.
So I kind of got lost here.
Oh, it's what the pink tab is for. So what are we looking at?
It's day times eggs. It's telling me non-numeric.
Oh, it's because I made a mistake because you can't multiply a word times a number of eggs. So I went back. That's a mistake. So then I did that. And so what you might want to do, that mult should be, yeah, so this is the error. This, why is it giving you an error there? Run that line.
This one.
Show me, just type in, hit return here and type in that. Let me just see what your data frame looks like at this point. Oh, you've replaced that with the Spanish flu data.
Gotcha.
So it's looking for eggs and X, and those things don't occur in the Spanish flu data.
Okay.
So, yeah. So when we did that down below, we replaced what's labeled dat. So that doesn't
Gotcha.
apply anymore. Yep.
Yeah.
So that way, our scripts are linear.
Uh-huh.
You can do something later that erases something that you did earlier. And so if you want to get that thing back, you have to go back up. And that's why it's useful when you're in our Markdown. That's why this is useful, because if you do find that you have to do that and go back up and redo something so that you can recreate something that you erased, you can just go back and find that easily.
Okay.
Yeah. Yeah, computer programs are always linear, and R is the same way. Yep, sure. Hopefully today was more useful than than Monday was.
Much more productive.
Good. All right. I think you're going to be a coder like I am. You're going to be prone to keystroke errors. So I'm having to constantly pay attention to exactly what I'm typing in, and you can see it already. I'm constantly making mistakes and having to go back and correct things.
Yeah.
But it would help if I was a better typist.
Yeah.